everything in cyber. So it's a good mix. With that, it's nice to be here. Thank you so much for having the SendGrep team. My name's Katie. I'm one of the account managers in California. So if you ever need anything, I can give out my contact information. We can get through Miriam. I would be happy to answer any questions you have alongside. I'm sure Erik would too. But with that, before we jump in, how many of you are familiar with SendGrep? A small handful. I was hoping more. We had a talk on Tuesday last week. Did anyone attend the virtual meeting? Few, maybe? Okay, awesome. So SendGrep is an application security platform. We cover code, so SaaS, SCA, open source, and secrets. Thank you. You can see here on screen a couple of our premier customers that we do have. We've been around for about 9 years, and a differentiator between SendGrep and many of the other solutions in this space is we're really meant for builders, which is excellent, especially with what's happening with AI today. So we have a very customized solution to a unique organization's code base, which I'll get into a little bit, and Erik can talk about as well how we work and what differentiates us. So one of the reasons SendGrep was created, software development is outpacing security, and that is only more relevant as we're going through this AI boom today. There is 5 times more likely that there's going to be AI-generated code containing a critical or high vulnerability. There's 100 or more new daily vulnerabilities that security teams are triaging, and it takes about 252 days to fix a vulnerability on average. So that statistics at the end is really important to think about. With AI today, it's going to become much more quick to identify a vulnerability, but it doesn't necessarily mean it's easier to fix the vulnerability quickly. And attackers are unfortunately also able to access those vulnerabilities more quickly. Another issue with the security for application security industry that we've come across and can help solve is it's kind of like whack-a-mole for application security vulnerabilities. There's so many within a code base. As mentioned, there's now more code that's being generated. Trying to figure out and prioritize what needs to be fixed and when to fix it is extremely important. For security practitioners, they're typically drowning in a lot of alerts. On top of that, how do you actually get developers to fix those issues within code is also a huge challenge. So trying to scale out a program to be able to fix vulnerabilities as they're created is something that is extremely important. But if you have things like false positives, it can cause a bit of a challenge there. With that too, if you're not keeping up with the pace of fixing these vulnerabilities as they're created, you could miss something that is critical, which is something you're hearing about more and more probably with the open source attacks that have happened in the last few months, things like Axios, for example. So a little bit about SendGrep's platform. As mentioned, we have 3 products. So we cover code or SAST, so custom code, supply chain, which is going to be third-party code scanning for dependencies, and then secrets. So these 3 are the part of our platform that we're focused on. We came to market initially with our SAST product, SendGrep Code. It is an open source solution too, so you can actually use it for free as well. We have up to 10 licenses in the community that you can leverage. Something that's really interesting, which Erik will be talking about a bit today, is really how AI is changing the AppSec world and what we're doing there. So on the kind of light purple here on the right side are workflows and plugins. So when you think about some of the problems addressed, too many alerts, a lot more code, trying to figure out how to solve and remediate these vulnerabilities as code is created, plugging into something like Cursor or Claude and being able to actually remediate and work with the AI agent is something that SendGrep is now able to do. And then secondarily with our workflow functionality, so that's something we can talk about a little bit or Erik might touch on, but basically leveraging AI within AppSec to build workflows for organizations to find things that are a little harder to reach. So pairing AI and SendGrep's engine together to get better deterministic outcomes so that you're actually finding those vulnerabilities consistently. So that's going to be what our multimodal is. It's our new branded AI plus SEMGREP engine. And talk a little bit about that. So multimodal is, again, using AI alongside SEMGREP's engine. It's actually allowing us to find 8 times more true positives, which is one of the biggest challenges, I think, in the industry for security practitioners is outside of having all these alerts and trying to fix them, how do you identify what is real and what is a false positive? Because typically a SAS scanner does not understand your code base. So that is something that SEMGREP is able to do right off the bat, actually analyzing the code base and understanding a little bit more about your unique organization, identifying what is likely a true positive or a false positive, and giving you the ability to almost vibe code to make some policies and rules around certain patterns or things that you know, for example, like an SSRF finding or for cross-file analysis that is unique to your organization. So right off the bat with that, we're seeing a 50% reduction in false positives, as well as layering on additional AI features like the workflow function, where we can find harder to reach vulnerabilities. So this is something that's really important. Erik will talk about it a lot. I think right now the industry is kind of trying to figure out, do I need AI? Can I build AI AppSec with AI today on my own and build a program, or do I need a solution provider? And being able to leverage the two together is what we're really seeing the most success with. So you can have that determinism. You can really build a platform with us that's custom to your organization, and you're going to get the same results consistently. Just touching here, I think this is my last slide. So again, we're weaving AI into our platform, as most organizations are. AI is really helping us to better detect vulnerabilities on top of the high false positive rate we had beforehand, to filter out the triaging the findings of code. So fewer false positives, being able to understand your organization's environment, being able to fix those issues as they are created. So understanding when a vulnerability is identified, providing a fix or patch for it right off the bat. And giving that input to the developers so that they can actually make those changes, and then preventing moving forward. So helping with building memories, that vibe coding to help triage decisions within the SEMGREP engine, making it so that you don't have these false positives pop up over and over again, and building trust with your development organization. So with that, I'm going to hand this over to Erik in a second. Really quick, we do have a free version that you can use of SEMGREP that has all the features and functionalities for up to 10 licenses. So you can actually leverage it there within our sign up here. You also can leverage the MCP server for free. And if you want to join our community, we do have a community Slack. The community of SEMGREP is really great. I think it's one of the most powerful parts of our organization. We started as open source, so we do have a really strong community there in the Slack channel. And then if you are interested and didn't see it beforehand, we have a QR code if you wanted a Lego set. It is a Game Boy Lego set. We will be pulling a raffle winner at the end of Erik's talk. So if you want to take a second to scan it, fill out the form, I will leave it up here while I transition this over to Erik. But thank you all.
Yeah. We need to turn off the mic or just leave it? Okay. Thank you, Katie. Nice to meet you all. My name is Erik. Let's see, let me switch to my slide deck. Share. No, I have a wireless mic here.
That one is for the online. That's for.
Oh, wait, I need both of them? Okay, got it. I can do that.
Okay, for the second one.
Got it, thank you. All right, hopefully now you can hear me better. So I'm from SEMGREP, as Katie mentioned. Let me move this out of the way. And I'm here to talk to you a little bit about my background and what I think is interesting about what SEMGREP's doing in security. So my name's Erik. My 2 areas of kind of background experience are in security. A long time ago, I started my working career in a field known as return-oriented programming, If that term's a little bit familiar, it's a technique for exploiting software using, for example, buffer overflow executions where there is data execution prevention, where you can't execute code that you've written. We found a way to circumvent that protection and exploit machines anyway. So it's a very black hat technique that I started my career with. After that, I got away from security and went into software building and product building, predominantly on machine learning, which we later rebranded to AI for the last 15-ish years. I've worked at a number of places, Google, Microsoft, LinkedIn, etc. And I am now a SEMGrep. My role here is to use AI both in our development process as well as in our products, predominantly in our products to help you all in your security needs, help our customers protect themselves against bad guys trying to exploit holes in their software. So that's the one sentence elevator pitch. Let me start with surveys. So Katie already asked how many people are familiar with SEMGrep. Let me ask a more general question. How many people work as part of their job, as part of their primary role, work in an organization that is producing software and wants to make sure that the software they produce is secure? How much, like, how many people are working in, like, that's a part of their job is security for their, okay. So it seems like about half of you. How many people are part particularly of the workflow or the process of making sure that of scanning that code or making sure that that code before it goes out or even after it goes out, finding and fixing the vulnerabilities in that code? Okay. So like most of the people that raised their hand in the previous slide, but not all of them. So that's kind of the context we're talking about here. SAS stands for Static Application Security Testing, which is one of the subsets, like one of the techniques, one of the categories of techniques you can use to check to make sure you don't have bugs in your code that are going to make you front page news tomorrow when somebody hacks you. And these are some of the kinds of keywords or techniques, types of vulnerabilities that SAS is particularly known for. I did, for the record, vibe code or vibe image generate this image. So if there are flaws in it, that's some LLM's fault, but you get the point here. And so these are the things that SEMGrep has historically been known for, and other products have historically been known for. SEMGrep is particularly known, as Katie mentioned, as an open source first product, is known as something that's very user friendly, is a builder community oriented product rather than this like kind of black box corporate thing that you kind of have to sign over your security program to and hope that it works. So you can write your own SEMGrep rules, you can build on top of it, you can build a program around SEMGrep. So it's very much a partner that you can use as an organization to protect your software. Typically, the application security teams or generally the security teams that care about their coding. So that's the kind of the background. Well, what happened after that is AI. I think that probably those two letters fit together in that order is something that you've all heard about almost every day for the past few months at least. So what did that do to the development process? This isn't even specific to software. What did that do to software development? I'm sorry, this isn't even specific to security. What did that do to software development? Well, previously you could write, I just realized I was standing in front of my slide. Let me help out a little here. You could either write code that would do something, or you'd have humans do whatever the code couldn't do for you. So you have this human-computer interface, HCI, you have this user interface, like, you click a button and the code does something for you, and then whatever the code can't do for you, you do it as a human. Humans are very, very capable. They can do just like, I don't know if humans can do everything, but they can do anything that you would conceivably ask a human to do if they're, a good hire. But they're very expensive. They're not very consistent. They're not as consistent. Humans make mistakes, they get tired, they go to sleep. They cost a lot, you have to pay people a lot more than you have to pay software to execute. And then software has the other opposite end of that trade-off, where software is very efficient, very consistent. We're not talking about AI at this point, just software. It's very consistent, very predictable, very cheap to run, but it can't do a whole lot. You have to program it exactly what you want it to do. You have to give it step-by-step instructions. It only follows those instructions as you want. Well, the new opportunity that AI and particularly modern AI presents here is that there are places in between that spectrum that you can write software for. There are prompts, which are a step from code towards humans, which is you can say, instead of generate these characters in this order, you can say, read this essay and give me a summary of it, as an example, as a one-shot prompt to an LLM, to a large language model. And it's pretty good at that. It's getting better every day. And that's a one-time execution, a prompt, a one-time execution. You can have it generate text, you can have it read text, you can have it summarize things, you can have it make decisions for you. Whether it makes a good decision or not is, it sometimes works and sometimes doesn't, just like a human, but it can do those things. And it kind of balances this trade-off. It's more expensive. It's a lot more expensive than predictable code, but it's still more reliable. It's more efficient and more reproducible than humans are. So it's kind of in this middle point. And then agents is another step towards humans. It's more human-like than one-shot prompts. but you can think of agents as using large language models to autonomously keep working on something until it's completed, until it's decided it's completed, or until you run out of tokens on your budget, and until your credit card starts bouncing with OpenAI or Anthropic. And so agents can keep going, like just like you can give a human employee of yours a task to go off for a week and execute on. They may come back with what you wanted, and they may come back not with what you wanted, but they'll go and execute for a while. You can do the same thing with an agent, and they can burn a lot of resources, but not as many as a human, and get a lot done, but maybe not quite as capably as a human. So that's kind of 2 points on the spectrum now. Well, so how does that apply to this security field, the area that we're talking about? So some research that SemGrep published a couple months ago is we did an analysis, our security research team did an analysis of a bunch of different kinds of vulnerabilities: auth bypass, indirect object reference, insecure direct object reference, path reversal, SQL injection, server-side request forgery, et cetera. These are different kinds of vulnerabilities that software can have. And we took known, like, here's a problem, it should be able to detect this. If it doesn't, it was a problem. And then true positive, we're going to define as it found the thing it was supposed to find. False positive is it found something that wasn't really a problem, and it's wasting your time to review it as a security person. And then the true positive rate, how often did it find what it was looking for, or we wanted it to look for. And so what we find is that this is on Anthropic code. This is a little while ago, but on the relatively recent Anthropic model, it could find some of them, and it could find them it's impressive that it could find anything at all, because we didn't tell it, like, here, look at this one line of code. We just said, here's your code base, find stuff, and it did. But not very consistently. As you can see, there's a whole lot of noise, and it misses most things. And this was the result. So again, a useful tool, but not something that can find everything you need it to find. So what do we do with that? Well, large language model context, it uses the context. Unlike traditional rule-based static analysis, it will look at the variable names and infer meaning from them. It will look at the comments in the code and infer meaning from them. It will look at what order the code is written in sequentially and understand what the programmer was probably trying to do with that code, and then infer where the code doesn't do what it seems like it was trying to do without explicit instructions to look for that particular failure mode, which is something it's really, really hard to write a regular expression like rule for, because that's matching for the presence of code. It's hard to match the absence of code, et cetera. So it's got these really cool capabilities. And so there are certain classes of vulnerability that it is better at finding than a rule-based approach. Like a traditional, like most SAS scanning prior to large language models was using essentially, you write something, not a regular expression that's overly simplified, but something semantically similar to that's much more complex and symbolic, which is where the semgrep, semantic grep is a search tool, command line search tool in Unix, and sem is semantic. So that's where the name of the company came from, is you're searching your code semantically for certain patterns that you might want to implement. And that's not even security specific. You could look for all the cases where some bozo used this library in a way that I didn't want them to, but it's most practically useful for security. So these are some of the use cases that we have found large language models to be able to augment our platform to be able to secure customers' code much more effectively. And you can see the business logic of use is pretty interesting, because that's fairly vague. If you don't know what that means, you're a good company. But there's a whole lot of, like I was saying before, there's a whole lot of things you might mean for your code to do that an attacker could circumvent, that it's hard to know without a really strict documentation of what you wanted it to be doing. But a large language model can be pretty effective at inferring that for you. And there's a whole host of other things that I'll let you read, but and we're adding more every single day. It's pretty crazy what these things can find. So as Katie mentioned, we have a new product offering and messaging that I'm going to test out on you guys and give me feedback on live or afterwards. I'm going to be taking questions. I don't have enough slides to fill up the time slot I have allocated, so I'm going to count on you guys to generate questions. So please write them down, or make sure you don't forget them, because I'm looking forward to your questions. But so we have traditional program analysis, and we have AI-based analysis, and there's some overlap in terms of what I can find. But what we found is that there's a whole lot of things that aren't very effective to find with AI and are much more effective to find with traditional program analysis, and vice versa. There's a lot of things that are pretty close to impossible to find with this approach, at least with the normal implementation of it, and are much, much easier to find with AI. So this is what we mean by multimodal. It has these two modes of detecting vulnerabilities in your code. Before I'll talk to you a little bit more detail about how we do this, but like, let me motivate you to listen. Like, why do we even care? So here's what some customers have said. So there's some that are quotable and some that are more vaguely quotable. With SemGrep, I trust that a critical finding will be relevant to us. One of the problems that becomes obvious when you're building a detection tool is, can I find the bad stuff? Which is an important first principle problem. But the secondary problem, if any of you that actually work in application security or that receive these reports from SemGrep, you'll know if you get like 10 false positives, 10 things that SemGrep said you should pay attention to, and it turns out your developers are like, look, that's not a bug because it's checked for over here, you just didn't notice that, you're going to stop paying, you and your developers are going to stop paying attention very quickly. Just like if you get an alert from your phone and it's like, nothing happened, nothing happened, nothing happened, you're like, shut up, and you're going to put your phone off because you just don't want to hear it anymore, right? So false positive rates, relevancy is really important, and that's one of the things that SemGrep is really known for, is making sure that the things we alert you to get your attention for are very, very likely to be relevant to you. 92% recall. So recall is a statistical term for do we find the bad stuff or do we miss it? So 92% recall on known IDORs. What I like about this stat a lot is they had a library of IDORs, which again is insecure direct object reference, which is the most common bug bounty program vulnerability type. When you put out a bug bounty program as a SaaS company and people submit vulnerabilities to get a few $1,000s in rewards for finding something in you, oftentimes more than half of all those vulnerabilities are IDOR type vulnerabilities. That's the most common category, predominantly because traditional tooling hasn't been able to help you find it. And so that's the thing that gets through the filters, so to speak, out to the world. And we fixed that problem. So I'm very excited to say that I expect that percentage to go down a lot after more people start using this multimodal product. But they had this company that I can't name, social media giant, had a whole bunch of IDORs in their software that they fixed, they paid out bounties for, that they paid out hundreds of thousands of dollars for in aggregate. But they still had them, and they still had the code that they were in. And we could scan that code back when it was still vulnerable before they fixed it. And we found 92% of them on the first try, without any coaching, without any look over here, without any hints as to where they were. Just here's the code, find everything. And we found 92% of them off the bat. So this is SemGrep multimodal, not just large language models. 78% true positives on IDOR findings so far from another fintech unicorn, and then 88% precision. Precision means of all the things we report to you, how many of them are real vulnerabilities you need to fix versus noise that you could have ignored. And the latter category often means real vulnerabilities that you just happen to not expose to the internet because it's an internal only application for example, which is something I found interesting when I came back to the security world, is even if it is a real vulnerability, it's very clearly exploitable, it's very clearly cross-site scripting or whatever, if it's not publicly deployed, then like my employees aren't going to hack me. It's fine. So there's a pretty high bar for what's relevant for application security people, and we aim to be like really clearly hitting that bar for what they care about. So what are the benefits of SemGrep multimodal? And I want to talk about why we're doing this and then what we did to get there. So the four big areas of like dimensions on which you could evaluate a product like this, I think, are consistency of results, large language models. How many people have used a large language model and said, man, every single time I ask this thing a question, it gives me the exact same output. It's like really clearly consistent. Every time I use this thing, what it says makes sense. So no hands, that's what I thought. Like large language models are really, really powerful and cool, and I'm not trying to diss them. I use them every day, but they're not very consistent, and that's a problem we have to solve on our side because we have to turn this inconsistent platform into a consistent result set for you all, for our customers. Second, precision recall, which is like, do you find all the things that are bad, and do you find only the things that are bad? Not wasting my time with useless information. Cost. This is something that's really interesting because I think we're going through, the word bubble is overused, but I think we're going through a period of imagination and exploration as an industry where large language models could do almost everything, but they won't do almost everything. They'll do some things and then they won't do other things, right? But we're throwing money at this problem because who knows which things those are. So we're going to try everything until we figure it out, right? So people have almost blank checks. Like, some CEOs are like, hey, the more you spend on large language models as tokens as an employee, the faster you get promoted because we want people to be using these things. Like it's kind of that level of spend in a lot of companies. But that's going to end. That's not going to last forever. Eventually, people will have shareholders that need to make profits, right? And so we need to make sure that we're providing these platforms at a scalable cost, and that's an important factor here. We don't want to waste tokens. We don't want to waste compute cycles, and then latency is important as well. We don't just scan your code one time. We scan your code for every PR that goes out, if you choose. Every PR that goes out from one of your developers before it gets merged into the main branch, so that you don't ever get code that could be deployed to production that has vulnerabilities in it. We want to catch it before it gets to that point. And so it needs to be really fast because people aren't going to wait an hour for a scan if they just wrote it and they want to push it to production. That fast feedback cycle is really important for people. So it needs to be in seconds to minutes, not hours. So those are the four dimensions. And I'm going to talk about each one. Consistency. So you can see that this is research from SemGrep. So we're citing a open researcher here, Sean Heelan, found that of particularly interesting vulnerabilities that large language models were able to find, they would find them if you ran the exact same prompt with the exact same code with the exact same inputs, it would find it 8 out of 100 times, as an example. Or 66 of the 100 runs would find that there were no vulnerabilities at all. It would say this code is completely secure 66 out of 100 times. But 8 out of those 100 times, 8% of the time, it would find a really critical vulnerability that was really important to know about. I don't know how many security teams are going to run the same prompt 100 times just in case there's something on the 100th run that they needed to know about, right? It's very expensive. It's time consuming. You're gonna question your sanity if you get something different on the 100th time. So this is just one example of an analysis, but that the consistent result. We had a lot of internal debates about a year ago, like when large language models were around, but not quite as powerful and useful as they are today for code security. About whether consistency was an abstract theoretical problem or like a concrete, like this is going to burn your program right now kind of problem. And it's clearly the latter. If you run something only 3 times, there's a very good chance you don't find the thing you're looking for in any of those 3 runs. And so there's really important techniques within the engine to solve for that. What we found is that SemGrep multimodal, and these are some of the examples, SemGrep form incremental, 2 of the approaches we use internally. This is the variance. So the size of this vertical bar, the Claude code is the blue here, is the range of outcomes that you get from a variety of runs, from say 20 or 50 runs. So you can get anywhere from 0% precision, it found exactly no useful information, to 50-ish% precision on this particular benchmark. This is an open source library. And with our solution here, and this is from a little while ago, so it's gotten better since then, it's like 38 to 47% or something, a very small bar of variance. So in other words, we're much more consistent. We're on the high end and we're much more consistent. And you can see the same results with the other benchmarks as well. So these are some of the results we've gotten is that we found techniques to take the large language model's inconsistency and eliminate it and be consistent in a cost-conserving way. Precision recall is the same slide I had earlier, but basically what it shows you is that it can find some stuff, but not most of it, not most of the time, and it has a lot of noise. We have an approach. This is a system diagram. I don't need you to process this and understand it, but you're welcome to like take a screenshot or watch the YouTube video and pause it and look at it later if you really want to, or you can ask me about it. I'm happy to talk about it in detail because this is my team builds. So if you're in the Q&A, if you want to ask me about each little box means, I'm happy to tell you. But basically, we take your code, the code we're in a privacy preserving way. We're not publishing anything. Take your code. We run scans to detect certain traits of it, like identify what tech stack it's using, what web frameworks you might be using. We write SemGrep rules. So we actually use the AI to write deterministic rules to then go back to the like pre-AI world and execute efficiently. So to get some of that determinism, that predictability. We run the generated rules. We take each API that we detect and check to see if it's vulnerable for a variety of vulnerability types. We apply org-specific context. So you can give us what are essentially prompts, we call them memories, SemGrep memories or system memories, where you can say, hey, anything from this particular subsystem in my application, don't care if it's insecure, it's completely internal, it's a piece of crap, we're going to delete it next week anyway, just don't even worry about that thing. We'll never show you another vulnerability like that. It's just with that one sentence. You don't have to go in and configure things and click things. You just say that one sentence, we'll never show it to you again. Or you can say anything of this class from any of these 3 sources are really, really important to us. Always surface them like these are super important things, and we'll always do that. It's a very, very configurable high-level override information. So we take that org-specific context and kind of teach SemGrep what's important to you, and then we filter and output. So this is kind of a little bit of a behind the scenes. I won't bore you with, if I go into any more detail, but those of you that don't work in security are going to be like, why am I here? So if you have questions, then I'll answer them in the Q&A. Let's go back to the results. So we talked about consistency. This is the precision recall chart. So this is just one experiment we ran. Again, on some of those open source libraries that I mentioned earlier, where we have a bunch of human labels. We took every single endpoint and had researchers thoroughly evaluate what's secure and insecure. What we found is compared to Claude, SemGrep had 823% as many true positive findings. In other words, we found 8 times as many, a little bit more than 8 times, 8.23 times as many true positive findings, human verified findings as Claude did over the same code with the same constraints. And we had half the false positive rate. In other words, we reported a lot fewer things, but those things were the right things rather than the wrong things. So it's like both less noise and also more signal. It doesn't have to be a zero-sum trade-off between the two. Another example, another interesting data point is I always forget. I think this is the product manager, the head of product at Anthropic, if I remember correctly, that said they have a research, but I don't think they publish, but they have the code for it. But they have a research project which will scan every PR using Anthropic for code vulnerabilities, but it costs on average $15 to $25 per PR. And that becomes prohibitively expensive in an organization that has thousands of PRs a day, tens of thousands of PRs a day going through. We are a very small fraction of that cost to scan your PRs for the same. So long story short, we can apply the same techniques, but only when it's appropriate, only in the ways it's appropriate, only spending tokens where it makes sense. And the last of those four axes I mentioned is speed. So it's important to be able to find all the vulnerabilities in your ancient code that's gone back years. But as I was talking to one of the attendees about earlier, the mean time to exploit, which I have this slide, but I don't have it in this deck. Mean time to exploit of a vulnerability from when it's discovered to when somebody's published an exploit for it and is taking advantage of it in public, went from years ago was months and then it was more recently weeks. And now it's about a day and a half. And this isn't the first time a bad guy somewhere in the dark web does something. This is when it's published by a white hat security researcher telling the world how to do it, is a day and a half after the thing was documented. So it's getting really, really quick to exploit software, and it's going to go down to hours and then minutes in the near future because of AI. And so what that means is you need to be able to scan before your code hits production, because by the time it gets in production, even for an hour, you're probably going to be hacked, if not today, at least by next year, probably. And so you really can't afford for your code to get out vulnerable even for an hour into production. And that was not true last year. Last year, you could afford days, weeks before you really had to get it out. And so not only are we able to scan your code, that's your main branch code, your production code, we're able to scan every PR, and we're also able to plug into Claude or Cursor or any other development environment that you have through Model Context Protocol, MCP, or through other hooks, or we have an IDE plugin for Cursor, for example, or Visual Studio, more generally, any Visual Studio development environment. And so we can actually tell you as you're writing code or as you're vibe coding, either way, hey, that thing that was just outputted by either your keyboard or the agent that you're using to write code, there's a part of that that's insecure. And it will tell you that as it's writing it, not like an hour later or 5 minutes later. Like as soon as it goes up to your screen, you can have a trigger which will automatically scan it with SendGraph and see if it's vulnerable. So we can prevent that code from even going to PR review. Like you don't even have to be embarrassed that your coworker saw it for a second because it was fixed on your laptop first. Okay, so I'm gonna go into a demo. Is a demo like, let me take a vote if nobody wants to see a demo. How many people want to see a demo, a live version of this? Okay, cool. All right, let me do that. Let me zoom in. Is that big enough that you guys can see if I stand out of the way? Okay, so this is what SendGraph looks like. This is the platform. This is our demo environment. I'm going to start by going to, this is the homepage. So what you can see on the left here, as Katie mentioned, there's 3 product SKUs. There's code, which is we scan what you wrote. There's supply chain, I'm going to go out of order. Supply chain, which is your software most likely depends on third-party code, open source code or other third-party code that you didn't write, that you don't control, but that if it's vulnerable, you're vulnerable too. And so that's the supply chain product and team. And we scan those dependencies, we immediately flag when they're malicious, and we help you figure out whether your code is actually using the vulnerable part of that code or it's using a different part of the library. It's just the same, it's part of the whole library. And you can say, hey, at some point you should probably upgrade the versions, but at the moment it's safe not to, because you're not using just to make sure you don't use this one library, this one piece of the library, because it's vulnerable. And then secrets is like, did you check in passwords? Did you check in API keys into your code? That if your code got leaked, it would be a problem if people would have access to things. So I'm going to focus on code for a second. So let's say, for example, this is one of your, this is GShop, which how many people have heard of GShop before? Okay, so this is like a known vulnerable software application that's on the internet. It's very commonly referenced when somebody's like, I can find holes in GShop, because it's like the thing that was published so that you can find holes in it. And so we're just using this as an example. So let's say this is one of your repositories. You can see recent scans, and you could say, here's the new part. You can say run a scan. And we have rule-based, this is the multimodal part. You can say rule-based detection, which is what we've had up until a few months ago. Or you can have, and this is like broadly released at RSA last month. You can say, I want a new AI detection scan. So you can scan a certain branch. You can enable or not enable weekly scans. So you can do a one-time scan, which I'm going to do for this demo here. Or you can say, I want every week I want you to rescan this thing. And then you can kick it off. And it will use a combination of agents with these prompts, like all the stuff that I just talked about building. And it will show you the results. And you over here to the code section. And then you can see, what did we find? So it's grouped by vulnerability type here. So we can see SQL injection, insecure direct object reference, and then a bunch more. And then for each one, this is a vulnerability that we found that you should pay attention to. You can click into one of them as an example, and you can see here is what's going on in the vulnerability. Here's the description. This is not a standard boilerplate like add blind, you read it once and you never pay attention again. This is rewritten for every single piece of code. So you can see, like, if you look at get_groups, this is referencing the actual variable names and function names in your code. So this is like customized. The impact, like what would somebody, if this is a bad thing, if this is real, and if it does go to production, what does this mean somebody can do to you? Spells it out very simply. Exploitability, we can show you how somebody would exploit this thing, like how would they go about taking advantage of this vulnerability, and then what do you do to fix it? So here's the code. Here's what you need to do to make it not vulnerable. We also have fix guidance, which this is another new thing. It's called auto fix. One click, you can generate a PR. Covering up the button. You can generate a PR, which will in less than 2 minutes, typically less than 3 minutes, it will generate a new PR with all the fixes that are needed, with all the documentation, get a really nice PR description of like what was wrong, how do we fix it, how you can test it, etc. It'll send it to the team that owns this particular piece of code, say, please review and merge this vulnerability. So you can just go through and go bing, bang, 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 fix all my issues. You don't have to know them. You don't really have to understand the issues. You could just fix them. So it takes a lot of the work away from triaging, because if you could fix it that easily, why even bother finding out if it's high priority or not? And if that's not your process, you can also send it to Jira. You can mark it you can ignore it. You can tell us why. You can say, actually, we don't care about whatever this is, backend web, open web UI routers groups, because we've decided that that's allowed to be insecure because it's only accessible to our contractors and they're fine or whatever. So you can also teach the system. If you say something here, it'll teach the system and it will not show you similar issues in the future that you don't find interesting. So that's what I want to show you. Actually, I could probably generate the PR, but I don't know if you guys want to wait that long. And then
Code,
yeah,
that's a highlight one? Is that the one that we need to fix?
yes.
Or is it all the code we need to fix?
Yeah, good question. So the question is, when it shows the code, is it just showing the part that we need to fix, or is it showing everything? This is a little bit in transition. So this is the code that's vulnerable. It'll show you the actual code. If you have access to the code, it'll show you the code. That you can configure how much you're willing to share your code with us, and there's certain settings where you don't show it to us, but it'll show you all the code where the problem is. If the fix is very simple, if it's in one, like we don't want this to be a huge like complex code browser, because you already have GitHub, GitLab, whatever source code manager you're using. So if it's a very simple fix, then we'll just show you like add this one line or change this like one character to this other character or whatever. If it's a complex fix, that's where you need to go to this PR that's being generated. You just click on it, and it'll say, here's the before code, here's the after code, here's the diff. It'll have a little like, this is why. It will usually document itself. Here's a comment for why we had to fix this and why we did it this way. So it'll be very clear what needed to be fixed from the PR that you generate.
And does the human need to say confirm to fix, so then I can actually fix the code? So because it's side-by-side comparison, so but is it automatically fix it from here, or do I have to push a button and confirm fix?
So the question is, do I have to push a button to confirm that it's fixed? There's whatever your policies are for deciding what code gets merged, you have to go through that, right? So if you have a policy that at least one third-party reviewer needs to review the code before it gets merged, which is pretty typical, then that person will need to confirm that they're okay with this code getting shipped. There's a separate question of did it fix the issue versus just can this code be changed? Like hypothetically, the fix could make the code better, but not better enough to fix the issue. So what we'll do is we'll automatically rescan the code with this new update right after it's merged and say, okay, now the issue is no longer there, we've verified. Or actually, there's a related issue that's still here. That kind of uncovered another issue. Like now you need a new fix for this one, for example. So hypothetically, if the code is still vulnerable after the fix, it would resurface that issue and suggest a new fix. Any other questions at this point? I think that's my whole demo. Let's see. Here's the PR that's fixed. So in that, while we were doing that Q&A, it generated the PR, and this is GitHub in this case. Add group membership check to get group info by endpoint. Here's what changed. Here's why it changed. Here's the SimGraph finding details. And then you can see the file change. And this is just GitHub UI. This is not something we built. The PR is what we generated. But you can see we add this little section to check to see if you're not an admin, you can't do these things. And now it's secure. So this is an example. The AI just did this real time while we were talking. And if I can go back to the presentation. So what do we show you? There's memories. Like I said, you can tell us something specific to your organization where the AI gets better and better at learning your particular organization, not just code in general. And it says, I care about these things. I don't care about those things. I want you to focus here. I don't want you to focus there. These kinds of like if somebody could steal the password or credit card information, that'd be really detrimental. But if they can find out what list of books we sell, like that's the whole point. It's public catalog. It's fine. Like it should learn that stuff automatically. But if it ever doesn't, you just give it one line instruction. It will generally learn. We've had customers, huge development team customers that said they had like this one class of vulnerability or this one class of issue where they would say we had a lot of noise, like we were reporting things they didn't care about. They put in literally like a one sentence directive and then they never had that problem again. Like it's just wiped out all the noise. So we've had a lot of success with memories here. Auto triage, which is what I just showed you. Sorry, auto fix is what I just showed you, which is we can generate PRs to fix these issues. And the auto triage filters out false positive issues and it shows you things like takes away the things you don't even need to bother auto fixing. And users, when we have users evaluate whether we were right or not, they agree with the auto triage decision 96% of the time. So that's like largely they just don't ever look at the things we auto triage out because they trust us. A couple more stats. SemGrep Multimodal produces 8 times as many true positive findings as large language models. Users agree 96% of the time, as I just said, and we could generate a PR in under 2 minutes, which is what you just saw me do a second ago. One more quote. SemGrep's contextual understanding was comparable to the analysis of one of our senior security engineers. So when I joined this company about a year ago, the CTO would tell me, we aspire to be a junior engineer. We aspire to be seen by our customers as like a junior security engineer, like good enough to be like the intern or like the new hire on the team. Like we're not gonna have all the business context. We're like, let's not get ahead of ourselves. At this point, we have customers unsolicitedly telling us that we're comparable in our analysis of their security program and our findings as a senior member of their team. So
You're just going to put senior security engineer out of jobs.
I hope we don't put them out of a job. I hope that we put them out of the wasteful part of their jobs. Because as I don't want to point fingers, but several of you mentioned that you're in security. I think application security is one piece of the overall security program. And there's like, humans just do dumb things. And like, I need to train these people and like stop installing software that's obviously malicious. And like, there's all kinds of things security people need to do. I hope we can make this part of the job a lot easier. Any questions?
What's the log for the auto triage look like? Is it something you can part of your documentation?
What's the what for auto triage?
So when you do a triage, discussion that goes on.
Yeah.
There's auto triage. Does it produce an equivalent to that discussion that you put in a log for the security for that?
Yeah. So the question, I'll repeat the questions in case the live streamers don't hear them. The question is, when you're doing auto triage, when you're recommending a triage decision, when humans are doing triage, they have back and forth discussion, thought processes, et cetera. How do you document what you're deciding? There are, so the short answer is it's right here. So it says likely true positive and agree or disagree. Actually, the most common thing is that there's a description here. We think it's a true positive because, but we actually moved that to this section because we have to be, you can see this is my product design side of me, not the security researcher side of me coming out, but like we like, on the team that actually builds this UI, we actually originally had the text here explaining like, here's why the bullets, why we either think it's a true positive or false positive. And SemGrep disagrees with itself quite a bit. We'll produce a finding and then we'll say, we're pretty sure this is a false positive and you can ignore it, but double check us here. So if we're ever not completely sure, we'll surface to you why we think you can ignore us, but then you can easily say ignore us. So hopefully it's clear. But we found that it was redundant with this description section, so we just moved it here. So the short answer is this section right here should tell you why we think it's relevant.
Right. So like with Atlassian, right, you have that triage step.
And
in my past experience is that triages are worthless because you have one person says it's this and the other two people are busy drinking their coffee and the errors don't get fixed.
Yeah.
But we have to put it in Atlassian for document.
For auditing reasons. Yeah. So the question is like, in his past experience with Atlassian, you have triage discussions that don't end up being very useful because people either aren't paying attention or just have to write down kind of busy work answers. I think that the core, I'm a big fan of like, let's cut process and get to the root of why we're doing this activity. And here, I think the idea is, look, we're either going to fix this, let's just auto fix it. If it's only one button to generate a PR to fix something, to me, the barrier for how much it matters to determine whether it's worth fixing or not is really low at that point. Because if you just have to click one button to generate it and the PR is good enough that the person receiving it just has to click one button to merge it, or like, let's say like 5% of the time they think it's not a good PR and they have to go rewrite it. But if it's not a huge percent of the time, to me, the barrier is low. The question really is like, if this is potentially exploitable, let's just fix it. And if it's not potentially exploitable, then why are we talking about it? So part of the answer is I think we should just get quickly to, can it be exploited? And so the idea here is, instead of saying hypothetically, like here's what would need to be true for somebody to exploit this. And if you could say, okay, but the attacker can't have an authenticated session because there's this other thing that we know about that the system didn't seem to notice, then all right, it's no longer it's a false positive, it's no longer exploitable, and we can say exactly why step 1 out of 3 is a fail here. So the goal here is to make it really clear what you could use as a basis for arguing that it's relevant or not.
Sometimes you have to find something in triage. The easy solution is trivial. And then someone thinks and takes a deep breath and they go, well, if I take that warning out of the Linux kernel, suddenly SSL won't be secure. Oh, wait. And then those are kind of problems that you can't solve with AI.
Right.
We can only solve with a human looking at it that knows
Yeah.
the Linux kernel, for instance.
Yeah, I would hope that we would encourage our AI to be really reluctant to just cover up, warnings or issues rather than directly fixing them. And sometimes the AI does that. Like one of the failure modes is if you generate a PR, sometimes it'll say like, look, I don't know how to fix this problem. Like I don't have no context, or like I just don't know how to. So you'll actually get that error message occasionally, not very often, but occasionally it'll say like, look, this is too complicated of an issue. I tried to do this, but it didn't work. I tried to do this, but it didn't work. You're gonna have to solve this problem for me. Human.
That's exactly what you want from a triage, is the AI or something, the triage team to elevate the issue.
Yeah.
Then it can be looked at with the appropriate experts.
Absolutely. Yeah, totally agree. Any other questions?
No, that's good.
Okay.
So
Carl?
I came across something on the internet. I want to ask you guys something.